All right, this is 2008 number 2, and you can use a calculator with this question. Hopefully you've read the question and you understand that we have a concert ticket and people waiting in line and all that stuff. Part A, use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30. Show the computations that lead to your answer. Indicate units. Okay, so now they want a rate. A rate means a derivative. Here's the problem. All we have is a chart. So I don't have an equation that I can derive. I don't have a graph that I can find the slope of. So I have to use this chart to find a rate. Well, before we knew a derivative, we used slope of a secant. And that's what you have to realize. Based on the information given, if I want a rate, I need a derivative. A derivative is a slope. So this is what I'm trying to approximate. The derivative at 5.5. So I'm going to find the slope of the secant line surrounding that. So I'm going to do L of 7 minus L of 4 over 7 minus 4 and get these values from the table to find the average is about 8 people per hour. And remember, the question said in part A that you are estimating. So that's a clue that you're not going to have an exact derivative. So there we go. Part B, use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours. If you recall, when you want the average of something, you integrate that something. If I want the average number of people waiting in line, then I need to integrate the number of people. So I need to integrate, if I look at this, I want to integrate L of t. But then I have to divide by the 4 hours that we're talking about. Now here's the big problem. To integrate L of t, again, that's where the trapezoidal sum comes in. We have to approximate the area under the curve. So I'm going from 0 to 4. I'm doing 3 sub-intervals, so that means 3 different trapezoids, sketching out the points based on the chart, and I'm finding, let's see here, I'm finding the area of each trapezoid, adding them up. I get 621. So 621 is my approximation of my integral, and I have to divide that by 4, and I get 155.25. So therefore, the average number of people waiting in line during the first 4 hours is 155.25. Again, we have a calculator, but since we only have a table to work with, then we're kind of stuck doing some approximations. Part C. What is the fewest number of times at which L prime must equal 0? Give a reason for your answer. Okay, this is a little tricky. What I did for this is I sketched out all of the points that they gave me. And so I sketch it, and as you can see, I have a function that is increasing, decreasing, increasing, and then decreasing. Now here's the key. In the original problem, they told me that it's twice differentiable. What that means is that I can take the derivative 2 times. Well, if I can take a derivative, then my function has to be continuous, because we all know differentiability guarantees continuity. So therefore, I know, based on this sketch here from 0 to 9, that I must have at least 2 maximums and 1 minimum. I could have more, but those are guaranteed. So that's what my explanation has here. L of t is continuous and differentiable, so there must be a max on the interval somewhere between 1 and 4 and somewhere between 4 and 8, since L prime changes signs from positive to negative. We have the change in increase to decrease, and then I'm guaranteed to have a minimum on the interval 3 to 7 because I have this sign change of negative to positive. Therefore, I'm guaranteed at least 3 times that L prime will equal 0. That was tricky. Finally, let's see, part D. The rate at which tickets were sold from 0 to 9 is modeled by R of t, and this is measured in tickets per hour. Based on the model, how many tickets were sold by 3 p.m. to the nearest whole number? Okay, this is tickets per hour, so if I integrate that, I'm going to end up with just tickets. So this one really isn't bad. If you look at part D, I'm just going to integrate R of t from 0 to 3 because those are the 3 hours that we're talking about. When I integrate that equation, that's where you plug that into I1, integrate it on your calculator from 0 to 3, you get 972.784, but they want you to round it to the nearest whole number, so you're talking about 973 tickets. And again, you have a calculator for this entire problem, but you don't even use it until part D. So don't let that throw you off. Hopefully you understand that problem. Good luck.